are going to learn iterative method. Now, what is the iterative method? Iterative method. This one is also known as a fixed point method. Fixed point method. And sometimes this one is also known as a successive approximation method. Successive approximation method. So, as we know that iterative method is not a bracketing method. This one is a non-bracketing method. So, first point, this one is a non-bracketing method. Non-bracketing method. So, how we find the solution with the help of a iterative method? First, we try to understand with the help of a geometrical interpretation of this method. So, suppose y equal fx be any algebraic or transcendental equation. Now, in iterative method, first of all we write fx in form of a x minus 5x. Means we break this function into a two function. First one is a x and second one is a 5x. So, if y equal fx equal to 0, and meaning of this one, we try to write fx in form of our x minus 5x equal to 0, means x equal 5x. We try to write first the given algebraic and transcendental equation in the form of a x equal 5x. Now, geometrical interpretation of this method, how we find the root with the help of a iterative scheme. So, if alpha is the root, then f of alpha equal to 0. What is the meaning of this one? Alpha equal phi alpha. So, here there are two functions, x and phi x. So, if we plot y equal x, so here if we write y equal x and y equal phi x. So, y equal x, if we plot this one, so this one is a what? This one is a y equal x. Y equal x. This one is a function y equal x. Now, this one is another function. Suppose here, this one is a function like this one. This one is a function. This one is a what? This one is a 5x. This one is a 5x. So, what is the root? If the value of a left hand side equal to the right hand side, geometrically we say that this one is a what? This one is a point of intersection of these two functions y, x and 5x. So, the root exists at this point. This point is a what? This point is a our root. This one is a what? This one is alpha. This one is a alpha. This point is a alpha. So, at this point, what will happen? At this point, what is the value of this point of this straight line? This one is alpha, and what is the value of the function? This one is a phi alpha. So, what is our aim? Our aim is now to find out this point of intersection. So, initially, we assume that we take any points, any arbitrary point, and assume that this one is a what? This one is our means an initial value. Suppose we start from the x0. So here, what is the value of a function? Here we write x1 equal what? Phi x0. What is the meaning of this one? X1 is a what? Value of the function, value of a phi x. So this one is a x0. So what is the value for this one? Phi x0. Find of an intersection with y equal x. This one is a nothing else x1. So here this one is a what? This one is our x1. Now at x1, what is the value of a function? Suppose value of a function is a what? Phi x1. This one is the value of a function. Value of a function. So this one is a value of a function, this one is a phi x1. This one is a phi x1. Now, point of intersection with x axis or y equal x. This one is a this one. So this one is a nothing else second approximate root. And here we just consider this one is a what? This one is a second approximate root x2. And what is the value of a function? Here this one is the value of a function. So in this way, if we continue this process, we move to nearer to the actual root. Nearer to the actual root. So similarly here, if we consider x3 equal what? x3 equal phi x2. Similarly, xn plus 1 equal what? Phi xn. Phi xn. So phi xn. So here, this one is a what? This one is a iterative scheme of a what? Iterative scheme of a fixed point method, successive approximation method, or iteration methods. So this one is the iterative method. So we start from any point. So here, this one is our actual root, this one is alpha. This one is alpha. So you may see here, we take first point x0, this one is the left hand side from the actual root. Then we find a second approximate value, this one is the right hand side from the actual root. Then we get in a left hand side, right hand side, left hand side, right hand side, means we approaches, x0 approaches from right also and left also and right also. So means a sequence of numbers means x0, x1, x2 up to xn converges to our actual root. So x0, x1, x2 up to xn converges to our actual root alpha. So this one is also known as a spiral convergence. So there are two things, spiral convergence and spiral divergence. So in this case, slowly we move, means spirally we move where? We move to our actual root. So due to this reason, this one is called what? A spiral convergence, means a sequence of iterative values x0, x1, x2, xn, if we spirally move to our actual root, then this one is called what? A spiral convergence. Similarly, so what is the advantage of any non-bracketing method? There is no need to find out means a lower bracket and upper bracket. And we choose any value arbitrary. Now, suppose here we consider this one x and y, and this one is a y equal x, and we consider such function like this one is a function, this one is a function, this one is a function, phi x. Suppose this one is a phi x and this one is a y equal y equal x. Now, if we choose initially this value, this one is a x0, this one is a x0, suppose this one is a x0, we choose initial value, this one is a x0, this one is x0. So, what will happen? Point of intersection with y equal x is this one. Now, what is this one is the first approximate value, this one is the value of a function, phi x0, and what is the value of x1, x1 equal to what? Phi x0. Point of intersection with y equal x. So this one is a what? This one is a second approximate value, x1. Now, similarly, now this one is a point of intersection. Now if we try to find out, this one is a value of function, not a point of intersection. This one is a what? This one is a phi x1. This one is a phi x0. This one is a phi x1. Phi x1. If we find a point of intersection with this one, then this one is a what? This one is a x2. x2. Now, actual root lie here. But if we take the x0 initial value nearer to the alpha, but in a first iteration we move far from our actual root. In x2, more far from the actual root. As the number of iteration proceeded, we move more far from our actual root. So, this one is a case of divergence. So, in this case, you may see this one is a what? This one look like a stair, and due to this reason, this one is called what? A staircase. A staircase. A staircase. A staircase, convergence and divergence. Previous one is a what? A spiral convergence, and this one is a staircase divergence. If we move far from this one, means if we take another means a graph and look like this one, means this one here. So what will happen here? This one is a y equal x, and we consider this one is a case, this one is a graph, this one is a phi x, this one is a phi x, this one is a phi x, and this one is a y equal x, Now, if we consider the first approximate value here, x0, then this one is a what? This one is a phi x0, and point of intersection is y equal x. This one is a what? A perpendicular here, and this one is a second approximate value. This one is a x1, and this one is a what? Phi x1, and point of intersection with this one. Now here you may see this one is also a staircase. This one is actual root. This one is alpha. Now, in this case, we take first approximate value far from the actual root. But after certain iteration, slowly we move towards our actual root. But in this case, we take the initial value nearer to our actual root, but as the iteration proceeded, we move far from our actual root. So this one is a case of a what? This one is a case of a staircase divergence, and this one is a case of a staircase convergence. And this one is also known as a monotone divergence, and this one is a what? Monotone convergence. And previous one is a what? Spiral convergence. And similarly, if we move far from our actual root, then this one is a what? This one is a spiral divergence, in previous case, in previous example, in previous graph. But in this case, this one is a staircase or monotone divergence, and this one is a staircase or monotone convergence. So, if we proceed from initial value to our actual root, then this one is a case of a convergence. If we move far from our actual root, then this one is a what? Divergence. Divergence of a sequence of approximate values. So, how we choose the correct value of x0? So, and how we choose the phi x? So, this one is a what? This one is also a one disadvantage of iterative methods or fixed point method. What is the advantage? Means we start from any initial value. There is no need to find out a lower bracket and upper bracket. But what is the drawback? If we start from any arbitrary value, maybe the sequence of iterative value diverges, means we move far from our actual root. And second one, it may be possible we move to our actual root. From here, we move far from our actual root. So, how we find a correct initial value so that we move towards to our actual root, not move far from our actual root. So, there is one theorem, means how we choose the value of initial value so that always the sequence of iterative values move towards to the actual root. Means, so first of all, in our iteration methods, how we choose the initial value. So first we write the y equal fx in a form of a what? X equal phi x. So now, if phi x is a continuous on a closed interval AB, and one of our real root lie between A and B, and suppose this class interval is a I, then mod of phi dash x, if less than 1 for all x belongs to I, then if we choose to any x, any value of x as initial value, then sequence of iteration means x0, x1, x2 up to xn converges to our actual or approximate real root alpha. So this one is means very carefully we choose the initial value x0, and also very carefully we write a function phi x. Now we consider one numerical example based on how we solve with the help of iterative method. Now suppose we consider fx equal x cube plus x square minus 1. Now there are different ways to write this one in form of x equal phi x. For example, here we write what? Here we write x equal what? Here we add and subtract x, then this one is the what? X equal x cube plus x square minus x plus x minus 1. So this one is the one form of x equal phi x. And suppose we denote this one is phi 1x, this one is one form. Another form to write this one as x equal 5x, here we write x cube equal what? X cube equal 1 minus x square. Then this implies that x is a what? X is a 1 minus x square to power what? 1 by 3. This one is another form. X equal 5 to x. Another form is a what? X square equal what? 1 minus x cube, and x is a what? X equal 1 minus x cube to power 1 by 2. One another form is suppose we write x square here, and this become 1 plus x plus 1 plus 1, and here this one is a what? This one is a minus 1. This one equal to 0, and if we simplify this one, then this become x equal 1 upon 1 plus x to power 1 by 2. This one is another form of x equal 5x. X equal 5x. Suppose this one is a 5 3x. This one is a 5 4x, not a 5 3x, 5 4x. And this one is a what? This one is a 5 3x. 5 3x. So there is a different form of a 5x. So there is a phi 1x, this one is a phi 1x, this one is a one form of x equal to 5x, this one is another form of x equal to 5x, this one is another form of x equal to 5x, this one is another form of x equal to 5x. Here 5x is a what? X square plus x cube plus x square plus x minus 1, and here 5x is a what? 1 minus x square to power 1 by 3. And here 1 minus x cube to power 1 by 2, and here 1 upon 1 plus x to power 1 by 2. So we choose such values of a phi x, means not a such value, means such function phi x which converges to our actual root phi by taking appropriate initial value. So suppose we consider x equal last one is means x equal suppose we write here this one in this form x square, then this become x plus 1 minus 1 equal to 0, then x square equal 1 upon 1 plus x, and x is a 1 upon 1 plus x to power 1 by 2. Suppose this one is a phi x. So here phi x is a what? Phi x is a 1 upon 1 plus x to power 1 by 2. So there is a different form of phi x. Suppose we choose phi x equal 1 upon 1 plus x to power 1 by 2. So now what is the value of phi dash x? Now here if we consider f of 0 is a what? Minus 1. F of 1 is a what? F of 1 is a what? F of 1 is a 1 plus 1 means a 2 minus 1. This one is a 1 plus 1. This one is a negative value. This one is a positive value. Then we say that if one real root lie between 0 and 1. Now, if we take any initial value from 0 to 1, this form of a phi x will converge to our actual root or not. So how we decide? So for this one, we find the phi dash x. Phi dash x. So what is the phi dash x? Phi dash x equal minus 1 by 2 into 1 plus x to power 3 by 2. This one is a phi dash x. Now what is the value for mod of a phi dash x? Mod of a phi dash x. Mod of a phi dash x. Mod of a phi dash x equal mod of this one is 1 by 2 1 plus x to power 3 by 2. Now if we put x equal to 0, now we try to examine what is the value of phi dash x between 0 and 1. So what is the value of phi dash 0? Phi dash 0 here, phi dash 0, mod of phi dash 0. Mod of phi dash 0 equal 1 by 2 mod of 1 upon 1 plus 0 to power 3 by 2. Obviously this one equal to what? 1 by 2 and this one is less than 1. Now what will happen at 1? So this one is a mod of a phi dash 1, mod of a phi dash 1 equal 1 by 2 mod of a 1 upon 1 plus 1 plus 1. This one is a 3 by 2 and obviously this one is a greater than 1. So this one is a less than 1. So total value become what? Less than 1. So mod of a phi dash 0 means at 0, x equal to 0, what is the value of a phi dash x? Phi dash x is less than 1. And at 1, what is the value of a phi dash x? Phi dash x is also less than 1. So between 0 to 1, there is a positive value. So all values, for all values between 0 and 1 means this class interval. In this class interval, for all values in this class interval, mod of a phi dash x is less than 1. So if for all values of this class interval, mod of a phi dash x is less than 1, then we take any arbitrary value between 0 to 1, any arbitrary value, and we proceed to find out our approximate root. So here this one is a non-bracketing method. Here only we ensure that the root lie between 0 to 1, but there is no any use to find out our approximate root, because this one only decide either we choose from this class interval or 0.5 to 1 or 0.2 to 1 for initial approximate value. Only we use this result, means f of 0 and f of 1 means a root lie between 0 to 1. Only we use this result to choose a initial value. So once we decide this phi x is a correct phi x because we able to choose we able to find out a class interval for which the value for phi x means here x equal 1 upon 1 plus x to power 1 by 2. 1 by 2, this one is a phi x, means x equal phi x. And we able to find out a class interval I. In this class interval, there exists a real root, because at 0 the value of the function is a negative, at 1 the value of the function is positive. So we choose initial value between 0 and 1. So what is the iterative scheme of a fixed point method or iterative method? Iterative scheme is what? X n plus equal phi xn. So what is the phi x? Phi x is this one. So what is the value for n equal to 0? x1 equal phi x0. x0 is a what? x0 is a first initial value. So here we choose initial value between 0 and 1 because between 0 and 1, this phi x, mod of a phi dash x, value of a mod of a phi dash x between 0 and 1 is less than 1. Now, if we choose x0 is what? 0.75. 0.75. You may choose any value between 0 and 1. So, if we choose x0 equal to 0.75, and then what is the value of x1? x1 equal phi x0 means phi 0.75, and what is the phi x? Phi x is this one, 1 upon 1 plus 0.75, and this one 1 by 2. So here we have already noted down the value of this one. The value of this one is a what? The value of this one is x1 is a what? x1 equal 0.75593. 75593. Now similarly, what is the value of x2? x2 equal phi x1. So phi x1 is the what? Phi, this one is x1, phi is 0.75593. So what is the value for this one? The value for this one is 0.75465. So here 0.75465. Similarly, we find x3. x3 equal what? x3 is phi x2. Phi x2. And this one equal what? Phi 0.75465. Here we noted down the values of what? This one is fx, this one is phi x, this one is x0 equal 0.75 is the initial value, then x1 equal this one x2, x3, x4, x5, and here be able to find out up to a 6th iteration, be able to find out the root correct up to a 4 decimal places. Root correct up to a 4 decimal places. Here we choose the phi x 1 upon 1 plus x to power 1 by 2. So in iterative method, first of all we decide what is the phi x, what is the form of a phi x, what is the correct best phi x from which we able to find out the root. Then we choose a class interval in which the root lie and mod of a phi dash x is a less than 1 for all values. Mod of a phi dash x is a less than 1 for all x belongs to I. So first of all we choose the phi x and choose the class interval, then choose the initial value, then use the iterative scale and putting the value of our initial value in a phi x, then we find the x1, then putting the value of x1 in a phi x again, then we find the value of x2, then we put the value of x2, then we find the value of x3. So here x0, x1, x2, x3, x4 like this one. So here you will be, if we closely observe this one is a 593, then this one is a 465, this one is a 493, then this one is a 487. So 593, this one, first this one decrease, then increase, then decrease, then increase like this one. So this one is a case of a what? This one is a case of a spiral convergence. In case of a staircase, this one either decreases, this one always decreases or increases, means approach to our actual root. But in case of a spiral, this one is a root, this one is a suppose alpha. First we move on left hand side, then move right, then we move left, then right. Means we approach from left, also from the right. So here, how we observe this one from the numerical result. We observe from the numerical result means first this one decrease, then increase, then decrease, then increase, means this one goes left hand side, then right hand side, then left hand side, then right hand side. but from left also we move to our actual root, and from right also we move to our actual root. And in case of a suppose numerical result indicate that this one towards 2 means the value slowly or fastly decreases, means approaches towards to our actual root, means this value is greater from this value is greater from this value, and this value is greater from this value, means a decreasing order or increasing order towards to our actual root, then this one is a case of a staircase convergence. So this one is an example of example of algebraic equation. How we solve the algebraic equation with the help of iterative methods. Next we consider, suppose we consider the transcendental equation and try to solve the transcendental equation with the help of iterative method. Suppose we consider fx equal cos x, fx equal cos x minus x into e to power x, into e to power x. Now suppose here we write this equation equal to 0 and we simplify this one, x into e to power x equal what? Cos x. Then x equal what? X equal cos x upon e to power x. Cos x upon e to power x. Now suppose we consider this one is a phi x. This one is a phi x. If we compare, this one is a x equal phi x. What is the value of phi x? Phi x become cos x upon e to power x. Now what is the value of phi dash x? Phi dash x become this one, phi dash x equal e to power x and minus sin x minus e to power x cos x divided by e to power x का whole square, e to power x का whole square. So now if we simplify this one, phi dash x equal what? Minus of sin x plus cos x divided by e to power x, Now we may also write this one minus under root 2 sin x plus pi by 4 divided by e to power x, Now what is the value of a mod of a phi dash x? So mod of a phi dash x is a less than, mod of a phi dash x equal is a less than under root 2 upon e to power x. Now if we consider the value of e to power x class interval is suppose we consider the class interval 0.5 to 1. 0.5 to 1, this one is a class interval, because at 0 the value is negative, at 1 the value is positive, so it's at x equal to 0.5. Suppose we consider the class interval 0.5 to 1. 0.5 to 1. Now we try to examine what is the value of phi dash x at x equal to 0.5. So what is the value for phi dash x? Phi dash x at 0.5 means this one equals phi dash 0.5 equal less than under root 2 upon e to power 0.5. So what is the value of phi dash 0.5 mod of this one. So already we calculated this value. This one is 0.857. 0.857. So up to a 3 decimal places, up to a 4, this one is a 7, 7, 6, like this one. So this one is a less than 1. Obviously this one is a less than 1, and phi dash 1, if you find out mod of a phi dash 1, mod of a phi dash 1, this one equal to the 0.5206. So at 0.5, the value of a mod of a phi dash x is a less than 1. At 1, the value of a mod of a phi dash x is also less than 1. So, and as the value in the class interval 0.5 to 1, 0.6, 0.7, whatever the value, means that there is infinite number of a value. But as we proceed from 0.5 to 1, the value of our x increases. As the value of x increases, the value of our exponential value also increases. Means denominator also increases. If denominator also increases, then this value also decreases from means a lie between 0.85776 to 0.5206. Between these two values, means x lie between 0.5 to 1, then mod of a phi dash x lie means this one is less than 0.8776 to 0.5206. What is the meaning of this one? For any value for this class interval 0.5 to 1, the value of a mod of a phi dash x is less than 1. So we able to choose any arbitrary value from this class interval to start the iterative method. So now we able to decide what is the class interval and what is the value for phi x, because mod of a phi dash x is less than 1 in a class interval what? In a class interval 0.5 to 1. So now we try to solve this one with the help of our iterative methods. So what is the value of phi x here? Phi x is this one. Now what is the iterative scheme? Iterative scheme is xn plus 1 and plus 1 equal what? Phi xn. So what is the value of x1? x1 equal what? Phi x0. Phi x0. And if we choose the x0, what is the interval? Class interval I is a what? 0.5 to 1. For this value, for this class interval, for this I mod of a phi dash x is less than 1. Now we choose any value from here. Suppose we choose x0 with a 0.52, nearer to the 0.5. Now what is the value of x1? x1 equal phi x0, means phi 0.52. Now what is the value of a 0.52? This one equal what? x1 equals 0.51595. 594. This one is the value for x1. This one is the value for x1. Now, what is the value for x2? x2 equal phi x1. This one equal phi x1 is about 0.51594. So, x2 equal, if we simplify this one by putting the value over here, means a 5 here, means a cos phi 0.51594 divided by what? Divided by e to power 0.51594 we find, if after simplification, what is the value of x2? x2 equals 0.51924. Similarly, we find the x3 equal 5, x2, x4 equal 5, x3, and so on. Means x10 equal what? 5, x9. Here already we noted down the values of x3, x4 and so on. This was the value of x0, we choose the 0.52. Then this was the value of x1, 0.51594. x2 means a 5x1. This one the value of 5x1. This one is the value of 5x1. 5x1. This one is the value of 5x0. 5x0. This one is the value of 5x2. This one is the value of 5x3. So, in a similar manner here, this one is a 5x14. This one is a 5x15. So, after 15th iteration, here, this one is a 5176, this one is a 5178. Means this one is a correct up to 3 decimal places. 0.517, 0.517. So, these are the two examples. One is a algebraic equation and second one is a transcendental equation.